After opening weka, select Explorer option. Here, open file is used to open any database, whereas open URL is used to select any URL, any source URL. OpenDB is used to link any database to weka. Generate is used to generate the data, and to edit and save are the other functions. Now we shall open a database using open file. Here we open Iris database. The Iris database has total of 5 attributes and 150 instances, where sepal length, sepal width, petal length, petal width are the attributes, and class is the attribute that needs to be calculated. In the classify tab, we can generate the data mining models on the database. So by clicking on choose here, we can select which of the model we want to use. So when we are using trees, you can select J48 trees. So the percentage split determines how much percent of data should be used for training and how much should be used for test. So I am giving a 50% split data. So on clicking start, the tree builds on the database. So we can see that the accuracy of the tree is 94% on this database. 71 are correctly classified and 4 are incorrectly classified. So you can even see a confusion matrix below, which determines number of items which are classified correctly and the number which are not classified correctly. Here 4 of the Virginica items are not classified correctly. They are classified as versicolor. If we click on use training set, then the dataset that is used for training will be used for test also. So if we build a tree on that, the accuracy has been increased. Yes, so 98% of the items were classified correctly and 2% of the items were not classified correctly, and we can see the confusion matrix below. We can also build neural networks on the same. So for building a neural network, click on choose, go to functions, select multi-layer perceptron and start. The accuracy that we got by using the neural networks is a little bit high when compared to the accuracy that we got by using trees. So neural networks are normally more accurate when compared to trees. So sigmoid node 0 to sigmoid node 5, these determine the input nodes and the hidden nodes given. So there are 3 input nodes here and 3 hidden nodes. So the weights of the nodes are also given below. In the cluster tab, we cluster all the data points together so that we can have a look of how all the points look when they are grouped together. So normally the type of clustering being used is simple k-means. So when we are using the training set for this, click on start, and now we are divided them into 2 clusters. We can see that when the full data is 150 and 100 of them lie in cluster 0 and the other 50 lie in cluster 1. Clustering also determines which of these classes fall into each of these clusters. So here we can see that in cluster 0 it's mostly with iris versicolor, whereas cluster 1 is mostly with iris setosa. One of the advantages of having cluster is we can divide the database into different parts using these clusters. So once we do that, if we use the same database for building models, we can get overall accuracies a little more higher than the normal ones. By clicking on associate tab, we can associate some rules to the database. Right now a priori is already present by default, or we can choose some other rules if they are present. We can even edit the rules by clicking on the white bar. We can change the class index and we can change the significance level of the rules, etc. By clicking on Visualize tab, we can view the relationships between each and every attribute present in the database. For example, let's view the relationship between the class and the petal length attribute here. As we can click on this, we can see on one axis we have class, and the other axis we have petal length, where x is petal length and y is class. So the blue dots here down represent the iris setosa, whereas the red dots in the middle represent the iris versicolor, and the green dots on the top represent iris virginica. This is how we can generate predictive models in weka. Thank you.